You're recording now. This is lesson 1.2 on representing and adding integers with tiles. Before watching the recording, please make sure that you have the 1.2 representing and adding integers with tiles worksheet with you, along with a pencil, and you need either a yellow highlighter or pencil crayon and a red pen or a pencil crayon. So if you need to pause the recording to get those items, please do so now. Otherwise, I'm going to continue. Now, ideally, at some point, you would have the opportunity to represent all of these integers and equations later on in the worksheet with real integer tiles. But for the purposes of the video, I'll just focus on drawing out the tiles. So that's why the colors are important, that you have them with you. Integer tiles is a really important visual representation because it helps you visualize how the integers are being added and eventually subtracted. So let's focus on the colors and what they mean first. So positive integers, if you look here at the beginning here, positive integers can be represented by using yellow tiles. So I'm just going to use the yellow here. I'm going to draw out the yellow tiles. And then negative integers can be represented using red tiles. So I'm going to draw a red tile here. So that's your basic representation. So yellow is positive. Oops. Yellow is positive, and negative is red. Okay, those are our basic representations there. Now, the key component of this lesson is understanding what a zero pair means. So a zero pair is when you have one of each. When you have a yellow and a red together, they cancel each other out, so they neutralize each other because you have what we call a zero pair. So you have a positive integer, so that represents +1, and then you have a red tile that represents -1, but they cancel each other out, so it's 0. So that's a zero pair. So that's a really important concept to understand when you're dealing with tiles, is the idea of zero pairs, especially when you're adding tiles. Now, make sure that you are familiar with what a positive integer means and what a negative integer represents too, and what a zero pair is. So before we get into the equations, let's just orient ourselves and make sure we understand different ways we can represent integers. So if you see here in the box below, it says sketch +6 in 3 different ways using integer tiles. And the hint is to think of zero pairs. But let's do this first example together. So I'm going to divide the box into 3, and you can do the same thing on your page as well. Divide the box into 3 different sections. Okay. Now, think to yourself, what is the most obvious representation for a +6? Well, you're probably thinking you'll draw 6 yellow tiles. So go ahead and draw 6 yellow tiles in the first box. And then make sure you label that, and we know that that definitely represents +6, or the integer +6, because it's represented by 6 yellow tiles. Now, there are many different ways we can represent +6. So we'll just think of 2 other ways. I'll give you another example here. So we're thinking of zero pairs. What if we did this? So I also want to represent +6 here. But another way of doing it is the following. Say, for example, I'm going to do 2, 3, 4, 5, 6. So I'm drawing 6 positive tiles, but I want to make one of these a zero pair. So if one of those is a zero pair, remember, a zero pair, if you have a positive tile and a negative tile, that cancels each other out. So we're actually left with +5 if that's the case. So we need to add one more to make it represent positive 6. Okay, because again, we're using the idea of the zero pair. So this is a different representation, although both this picture and this picture represent positive 6. Now, I challenge you, think of a different way that you can represent positive 6. So pause the recording and use maybe multiple zero pairs to represent positive 6 and see what you come up with. Well, I'm going to continue here. So I'm going to maybe do 2 zero pairs instead. So again, same thing. So I'm going to now I know I want 2 zero pairs. So I'm going to draw on purpose 2, 3, 4, 5, 6, 7, 8, because I know I want 2 zero pairs here. And notice, I should point out too, you always circle out the zero pairs so that you're defining them clearly, and you know you're left with positive 6 here, so you're left with positive 6 here. Also notice the way I've been drawing the tiles. When I have the positive and the negative, I'm lining them up vertically so the zero pairs are easily circled out. So I encourage you to do the same thing where you're lining up the positive and negative tiles vertically. Okay, so those are 3 different ways you can represent positive 6. They all represent the same value, but all done differently, again, using the idea of zero pairs. So if you look at number 2, it says in the box below, sketch -7 in 3 different ways using integer tiles. I encourage you at this point to pause the recording and come up with 3 different ways you're going to sketch -7. Now, the 3 different ways I will do it may differ from how you have it, but that's okay. You should be able to check your own work, just making sure you have the same amount of zero pairs and that what you end up with is the representation of -7. So go ahead and pause the recording. I'm going to continue, and hopefully you've come up with the first representation as being the simplest way to represent it would be 7 negative tiles or 7 red tiles. 1, 2, 3, 4, 5, 6, 7. So we know that representation is -7. So that's one way we could represent it. I am going to mirror what I did up above there. I'm going to go with 1 zero pair. Oops. As a different way to represent -7. Now, does it matter if negative or positive are on top? No, it doesn't matter. But again, I encourage you to make sure that you're lining up your tiles vertically so that the zero pairs can be easily circled out. I need to go 8 here. And then I'm going to circle out the zero pair here. So then this, I know I'm left with 1, 2, 3, 4, 5, 6, 7. This is also representing -7. I'll go a little bit further here in this last example. I'm actually going to go, okay, let's do 1, 2, 3, 4, 5, 6, 7, and I'm going to go 1, 2, 3, 4, 5, 6, 7. You might think I'm representing -14, but actually I'm not. 3, 4, 5, 6, 7. I'm going to circle out my zero pairs. Make sure, again, this is a reminder, you're circling out all your zero pairs so you can clearly see what you're left with, right? And in this case, 1, 2, 3, 4, 5, 6, 7, I'm also left with -7. So again, 3 different ways that you can represent -7, but they all show the same value. But you're using the idea of zero pairs. So hopefully by now you have a good understanding of what zero pairs are. Okay, so let's go to the next page and let's work on some equations. Okay, so actually the first example, if you go to the back side of the page, we're adding two positive integers here. So we've got positive 5 plus positive 4. Now, this is also a really important note too. Notice the use of brackets around the integers in any equation that you do from now on involving integers, you must use brackets. Even if the integer is positive, please make sure you use brackets around the integers themselves so it's easily separated from the operation in the middle, okay? Now, you probably are thinking to yourself, you know the answer of positive 5 plus positive 4, but you're still going to model this equation using integer tiles in the box below. So what I'm going to do to set this up, and you need to do the same when you are setting up your work too, is you're going to start off with the first integer in the equation, which is positive 5. So positive 5, how are you going to represent positive 5? How are you going to draw this out? You have 5 positive tiles. 1, 2, 3, 4, 5. Okay. And what's nice about this is it's the same sign. So then your second integer is going to be down below. So that's positive 4. And you're going to represent that with 4 positive tiles. Now, because we're adding the same sign, there is no need for 0 pairs here. So because it's the same sign, you're just counting simply the number of tiles you have there. I am going to rewrite the equation, so I'm getting used to using brackets with integers. Positive 5 plus positive 4 equals positive 9. Okay, and we know we've got positive 9 as our answer because we have 9 positive tiles in total. So that example is straightforward because you have 2 positive integers. Now, the next example is slightly different because this time you're adding a negative and you're adding a positive integer. So you're adding 2 different signs. Notice again the use of brackets, really important. So you're going to add negative 6 plus positive 9. Same procedure as before. You're going to start off with the first integer in the equation, which is negative 6. How do you represent negative 6? Well, should be 6 negative tiles. 3, 4, 5, 6 negative tiles. And then how are you representing positive 9? Positive 9. Remember what I said on the previous page. It's really important to line up your integer tiles vertically so that you can see the 0 pairs easily. So look at what I'm going to do here. So I'm going to do positive 9, 2, 3, 4, 5, 6, 7, 8, 9. Again, lining it up vertically is really important because now you can see what's going to happen. You must circle out the 0 pairs whenever you are adding tiles because this is part of how you show your work. So I'm going to make a note here. You must circle the 0 pairs. Okay, because now that's neutralized it, right? So you know you have 6 0 pairs. So what you're actually left with when you add negative 6 plus positive 9 is the remainder, which is positive 3. Okay, so again, note that it's very important to line up your tiles vertically so that you can circle out the 0 pairs. 0 pairs is the key concept when you're adding integers. I'm going to rewrite the equation below here. So it's going to be negative 6 plus positive 9 equals positive 3. Okay, and circle your final answer. We'll do one more example of two different integers as our example 4. Okay, let's move on to number 3. Now, number 3 is actually similar to number 1, where you have 2 integers of the same sign. You're adding 2 negative integers, negative 3 plus negative 7. Okay, similar procedure as the other examples. So you're going to start off with negative 3. How are you going to represent negative 3? 1, 2, 3, and 3 negative tiles. And then how are you going to represent negative 7? You've got 7 red tiles. 3, 4, 5, 6, 7. We don't have to worry about zero pairs because they are two integers of the same sign. So you're simply counting the total number of integers you have there, which you know that you've got a total of negative 10 if you add them all up. You're going to rewrite the equation. Negative 3 plus negative 7 equals negative 10. Okay, you probably have a little bit of room down below. Let's do one more example. Let's do number 4, where we're adding two integers of different signs. Let's say we're going to add, let's do positive 12 plus negative 7. Okay, now I challenge you to pause the recording now and try this one on your own first before you see how I do the example. So again, your last one is going to be positive 12 plus negative 7. Again, use the previous examples to help you. I'm going to continue. So again, as before, you start off with the first integer. You have positive 12. And then you're going to draw out 12 positive tiles, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then you're going to go negative 7. You're going to draw out and line it up down right underneath the positive 12. 1, 2, 3, 4, 5, 6, 7. Okay, so again, lining it up makes circling out the zero pairs very easy. Make sure you are circling out the zero pairs because this is part of the work you need to show when you're adding integers of opposite signs. I've circled out 1, 2, 3, 4, 5, 6, 7 zero pairs. What am I left with? I'm left with positive 5 tiles. So I'm going to rewrite the equation. Positive 12 plus negative 7 equals positive 5. And yes, it is important to note that if there is no sign in front of an integer, you automatically assume it is positive, but I'm just being clear with the purposes of this video that we have positive 5 as the answer. So again, the key concept when you're adding integer tiles, just to review and go back up here, understand the whole concept of a zero pair. So if you have one of each, then it neutralizes it, so it becomes 0. That formed the basis for understanding how we can represent integers in different ways using zero pairs, as we did with positive 6 and as we did with negative 7 here. Understand how much work you need to show when you're adding integer tiles or you're adding tiles using integers. So make sure you start off with the first integer in the equation and then the second integer. Make sure that especially when you're adding integers of opposite signs, that you're circling out the zero pairs and you're lining up your integer tiles so it's easy to do that. And again, so use these examples as a reference for you in the future.